In this video, I'll be talking about the most widely used activation function today in the world. That is the softmax activation function. The softmax activation function is one of the most popular and most widely used activation function in neural networks and deep learning nowadays. The mathematical equation of softmax activation function is shown here. It is equals to e to the power xi divided by summation of e to the power xj, where the range of j is from 1 to n. From this equation, we can say that the softmax activation function is not linear, since it has a exponential term. The softmax activation function converts logits or scores to its corresponding probability values. That means if we give a logit or score as input to the softmax activation function, the softmax activation function will return its probability values. Since the softmax activation function produces probability values, that means it must follow two conditions. Number one, that the sum of all the outputs of softmax, that means the sum of all the probabilities, must be equal to 1. And the second condition is that each of the output values, that is, each of the probabilities, must lie within 0 and 1. Now let's have a look at an example that illustrates how softmax activation function works. For example, we are providing an image of a dog as input to a neural network. So the neural network takes this image as input and it produces some logits or score. These logits are then passed into the softmax activation function, and the softmax activation function returns the corresponding probability values for those logits. And these probability values are the probabilities for each of the classes mentioned here. From the values of probability, we can see that it has the highest probability of being a dog. That means our neural network model tells that this image has a 77.5% chance of being a dog. And it has only 0.039, that means the least possibility of becoming a tiger. Thank you, everyone.